Hi friends, welcome back to techarkit YouTube channel. My name is Ravi. In this video session, we are going to see AWS certified cloud practitioner course. The next video is messaging services. So what are all messaging services and how they can help the business? AWS offers a range of messaging and integration services that can help business communicate with their customers, process data, and connect to different systems and applications. Messaging services can help businesses to communicate with the customer. Example, sending the messages saying that hey, your order is ready, your order is completed, or your order is in process, or delivery is in process, so and so the status messages will be sent, or billing messages would be sent to the customer based on the status, so that the customer is intimated based on the status, so you would be getting know the status. So what you can do here, so monolithic applications, microservices, tight coupling, loose coupling. So what are those application types, like what is monolithic applications and microservices, how we can do the existing infrastructure, right? The tight coupling infrastructure and the loose coupling infrastructure. So how you can do that, what is the difference between them, and let's see that. So here if you take the tight coupling versus loose coupling, here if you see on the left hand side, the tight coupling in the sense existing most of the applications which is not a microservices, most of the times they have the infrastructure with example ERP systems you have, right? ERP systems are tightly coupled, so they have the complete dependency on each and every component. So they have the multiple components in it, like the database servers, application stack, web stack, all this stuff. If the database stack is down, then the entire ERP is down. Or in middleware, if there is any web tier is down, then the entire service is disrupted. Like it is completely dependent, interdependent on one service to the another service. That's why it is called as a tight coupled systems. More interdependent systems and easier to develop. Example, so whenever you are developing any such a kind of applications, it is easy because it is a intercomponent, so you don't need to specially design anything here. Faster development, deployment, because it's completely dependent applications. So once deploy 1 second 2 3 4 steps, you follow this step by step process, right? Like one first deploy this, second deploy this, third deploy this, something like that, then the deployment would be easy. Limited scalability, because you have the tightly coupled applications. If you scale one component, so it is dependent on other components, that's why it has a limited scalability. High maintenance, because of course you have to maintain all the components, if whether the component is required for you or not, but you have to have that component in place, so that in cost wise licensing is high. And the maintenance, because you have to maintain multiple systems to maintain all the components intact, so that's the one thing. And risk of failure, this is the major one. If you are talking about the tight coupling and loose coupling, the risk of failure is, that's what I said. So if one of the component is failed, so the entire system to be failed, because they are interdependent systems. So if you come to the loose coupling infrastructure, loose coupling is less interdependent, because they are not, most of the times the dependency is less, that's why they call this as less interdependent. Increased scalability, because these are not dependent on each system, so you can scale their own. Improved fault tolerance, because they don't have a most interdependent system, because these are less interdependent, that's why it's improved in fault tolerance. Greater agility, so you can easily scale up and scale down systems. So that's what there's a greater agility you can do that. Data integrity is complex because they are multiple own systems. They are multiple their own systems. Dependency on other system is very less. So you have to maintain the data integrity between all these systems which are loosely coupled. Example, you have a micro services with a loosely coupled infrastructure, then it might takes the data integration between those microservices would be complex. Managing multiple services, like if you have a multiple services deployed on this loosely coupled infrastructure, would be you can manage them, but sometimes the integration for those data between the multiple services would be too hard, but still you can do that. But of course, what is the difference, main difference here? So the risk of failure in tight coupling infrastructure, and here it is a major improvement on that particular, and there is not much of a risk of failure here, but the data integrity between the services would be a complex one. Let's see what are the services available to tackle this infrastructure here on the AWS. AWS has a simple queue service which is basically used to queuing the request, right? So how you can do that? SQS provides highly scalable distributed message queue that enables decoupling of different components of a software application, making it more scalable and fault tolerance, because they are not interdependent. They are different microservices with a loose coupling infrastructure, but still there is a mediator between these services to have the messaging service. So the the queuing service will, what it will do, it will queue the requests between the multiple macroservices in SQS, then it processes. So that's why they are not interdependent, but of course they are less interdependent. Still they are dependent on SQS to process, but it is very less dependency. SQS allows developers to create and manage message queues that can be used to transmit any type of data, including text, images, and JSON. Messages are sorted in a queue until they processed by a receiver application. When a message is processed, it is removed from the queue. So that's how it's processed. So once message is sent to the SQS, unless the message is processed and received by the application, so it does not move it out of the queue. So it is a standard queuing process used best effort delivery approach, which means the messages are not guaranteed to be delivered in the order they were sent. So it's a standard queuing process, whatever the best effort to put it a parallel processing in place, so that whatever the process which completes earlier will be delivered earlier. And it uses fast in fast out process, FIFO, FIFOQ, fast in fast out. Example say that, so whoever comes first, he delivers fast, whoever comes next, he'll deliver next. So the first message comes and it processes and it delivers, the next message comes and it processes, delivers. So in way, whoever comes first means the timing of that message is fast, so it processes first, then the next message will be picking up and process. So that is called as a FIFO process, fast in fast out. Allows components to component communication using messages. Messages are processed in a asynchronous manner. So the next service is Amazon Event Bridge. Is a serverless event bus service offered by AWS. Serverless means the infrastructure completely is managed by the AWS, you don't need to worry about the underlying infrastructure in this case. That is called as a serverless event bus service. It enables developers to build event-driven applications by providing a central event bus that can receive events from a wide variety of sources such as AWS services, SaaS applications, custom applications, and more. Example, this is like just an event triggered processing. So I say that, hey, send some messages. Like example, I have uploaded some files to S3 bucket. So once S3 buckets triggers an event saying that, hey, this file is uploaded, then the event bridge will take that message and do an action. So you can define that, hey, if any event of uploading will be triggered to the event bridge, then you can do the further process like trigger one more event. Example, processing the file to the database, or scanning the file and uploading to somewhere else, or process the data of that file, something like that. You can define the process using this event based on the event. Example, that the data is uploaded to the AWS S3, then take that event and process that file to the RDS, something like that. Event bridge allows developers to define rules that route events to targets such as AWS Lambda functions, Amazon SNS topics, Amazon SQS queues, and more. When an event is received on the event bus, Event Bridge applies the defined rule to determine which target should receive the event. So that's the example here. So it's a decoupling infrastructure. Example, you don't need to depend on the microservice is not dependent on another microservice, because the microservice sent triggers an event rule. When the rule is triggered, the microservices will receive an action, then it's process that. So it is less interdependent, but it still depend on event bridge service, but it is still not completely dependent. It is a interdependent process. That's called as a decoupling infrastructure. Flexible event driven applications. So that's the more flexibility you have on event driven applications. So let's see what is the next service here. The next service is Amazon MQ, which is also contribute to your messaging services. Amazon MQ is managed message broker service provided by Amazon Web Services AWS that enables applications to communicate by exchanging messages. So it enables applications to communicate by exchanging the messages. Example, say you send hi, then it sends hi. So that's how the exchanging the messages. So it supports multiple messaging protocols such as AMQP, MQTT, STOMP, and OpenWire, and you can be used to integrate applications running on different platforms, right, programming languages and operating systems. So that's the major support can be provided by the AWS MQ. So it also runs Amazon Elastic Compute Cloud instances, so it can also run the MQ on EC2 instances and can be easily configured and managed using AWS Management Console, the AWS CLI, or Amazon MQ API. So you can also use AWS CLI to manage this one, or API calls. You can also use the API calls to use this MQ service. It provides features such as message encryption, message filtering, and message deduplication. So if you send the multiple messages in a duplicate manner, so it says that hey, it is a duplicated message. It can identify that in the queue, as well as automatic failover and scaling capability. Example, it can fail over to the service. The next one is Amazon AppSync, that simplifies the process of building scalable and secure GraphQL APIs. AppSync allows developers to create APIs that can fetch data from multiple data sources, including AWS services like DynamoDB, Elasticsearch, Lambda, and so example. So here what it can do is that it is actually providing the GraphQL API, so where you can fetch multiple data sets from the multiple sources like DynamoDB, Elasticsearch, and Lambda and other services. Then it can able to create a graph, right? The languages, right, for fetching the data from the multiple sources and combining them, building a real-time applications, mobile and web applications. Data synchronization between the services would be more helpful. That's what decoupling infrastructure do, right? It's not completely dependent, but it's less interdependent service, so that the messages, right, the data synchronization between the multiple services, how that communicates between the application to application. Data analytics you can also use for data analytics with this AppSync service. One real-time use case for the AWS AppSync is building a real-time chart application. So example, chatbots, right? Chat applications you can build. In a chat applications, user expect to see messages from other users in real time without needing to refresh the page or manually retrieve new messages. Example, so when some applications you send a message hi, then the reply is already sent. Sometimes you have to refresh your application to get the message synchronized, but this AppSync already have the data synchronization process in place, so you don't need to refresh the chat. It will automatically say hi, then it will send the hi, then something like that. The messages are flow in a real manner, real time, near to real time. It's not any delay whenever the message is sent. So that's the example, the real-time example where you can use the AppSync. AppSync can be used in a chat applications to sync a real-time chat information. So that's the real-time example for that. So those are the messaging services from the AWS. So this is the very important for the examination on the technology part. That's about this video. Thanks for watching. Stay tuned. Please subscribe to the channel for more upcoming videos and courses, and do share with your friends and family so they also learn along with you.